This kind of a framework will help us cure almost all the diseases known to mankind. We will live 150 years or more. There will be no premature death. We're talking about a technology that helps us create wondrous new materials. We will understand nature, weather, and we will model those things inside computers and then control them without hurting it. The countries or businesses who are going to own this kind of technology tomorrow will be more powerful than the countries who possess nuclear weapons today. This is the vision of the future that everyone is wanting to achieve. All what I explained seems nearly impossible to achieve. They're not possible to achieve today simply because the kind of computers used today does not have the right type of computational techniques to solve these problems inside a computer. But quantum computers has the ability to solve these kind of problems. It's a different type of a computation engine. In this video, we're going to understand what quantum computing is, how it can solve these kind of problems. For that, just to make things simpler, I'm going to start by playing a simple game. Let's play a simple game to understand this. We're going to play head or tail or the flip coin game. We will be playing this game with a computer. The game also structured in such a way so that it's going to help us uncover certain truth that we're going to discuss those details later. The game need to begin having the head side of the coin up. There will be 3 opportunities to flip the coin. The first opportunity is given to the computer and it can decide to flip the coin or not. Second opportunity is ours. We also can decide to flip the coin or not. Third opportunity is again given back to the computer and it also can decide again whether to flip it or not. For each of these turns, neither us nor the computer going to reveal our move to one another. At the end of these 3 rounds of play, the coin will be revealed, and if the final outcome is a head, computer wins the game, otherwise we will win the game. Now this is a relatively simple, seemingly boring game as well. If you play this game with a classical computer, the probability of you winning the game will be nearly 50%. The computer will have the same probability of winning this game. So there is nothing special about playing this game with a classical computer. And I'm not here to talk about playing this game with a classical computer either. If you play the same game without changing anything with a quantum computer, it has been proven that a quantum computer has the ability to win this game all the time, regardless of what you do with the coin. Whether you decide to flip the coin or not, the computer is going to win it all the time. Now this is magic. But what you just heard is a quantum theory in practice. Inside a quantum computer, you have qubits instead of bits that you find in a regular computer. Qubit is created by controlling the behavior of fundamental particles such as electrons and photons. When you talk about controlling the behavior, I think it is important for us to understand what exactly this qubit is. So let me explain that first. As you can see, there is a sphere and I have placed a nucleus at the center of this sphere. There is an electron getting attracted to the center of this sphere. The electron can move around the sphere and the sphere is acting like an energy level for this electron. Electron has magnetic properties, so it has a north pole and a south pole. So at a time, the electron can be pointing its north up or north down or in any other direction as well. The qubit value is, we say 1 when the north is pointing toward up, and if it is pointing down, then we say the qubit has the value 0. Since the electron can be pointing in any other direction as well, our qubit can have any value in between 0 and 1 as well. Additionally, electron is a quantum particle, so it possesses quantum properties. Because of that, electron can have its north pole pointing up and down at the same time too, which indicate that our qubit now can have value 0 and 1 both at the same time too. This is the magical superposition. Superposition is one of the most powerful quantum phenomena a quantum computer uses to do certain type of operations a lot faster than a classical computer. In addition to superposition, a quantum computer uses 2 other additional quantum properties as well. These are quantum entanglement and quantum tunneling. But in this particular video, I'm not going to talk about any of those, but I'll be mainly focusing on quantum superposition. And I'll be using some applications to help you understand how powerful this application can be. Yes, we need to get back to our game and try to understand what happened in that game. So when computer flip the coin, it get into this magical superposition and keep maintaining it while we do our flip as well. At the end of those 3 rounds of play, when the decision need to be made, the qubit collapses itself from the quantum wave function and arrive at a value. It does that with having the understanding to find the right combination of values that need to meet the desired output. And that is what make it win the game all the time. Now this is a bit confusing, I agree. But what is important for you to remember here is that a quantum computer does not demand you to have precise values. It does not want precise values. Rather, it considers potential options simultaneously with their probability of occurrence. So that's the key property that a quantum computer differentiates itself from a classical computer. Imagine having a 2-bit computer. 2-bit means you can have 2 different values considered simultaneously with that classical computer. The equivalent quantum computer with 2 qubit will have the possibility of considering 2 to the power 2 times more options simultaneously. Now imagine a 300 qubit quantum computer, which means that this particular quantum computer with 300 qubits can virtually consider more options than the number of particles you find in the entire universe. This 2 to the power 300 is bigger than that number. This indicates quantum computer become exponentially better at solving problems that need you to consider multiple options or impacting variables simultaneously and decide which combination of those values are best suited to arrive at a desired output. Now, with this kind of a computational power, a quantum computer can solve some of those problems that a classical computer cannot solve. As an example, 1 out of 3 people today have the possibility of diagnosing with a cancer. According to medical stats, 50% of 14 million cancer patients recognized every year are being treated with radiation therapy. Radiotherapy treatment need a radiation plan done upfront. The classical computer do the job today. In order to create the radiation therapy plan, you need to consider number of impacting variables. But given the limited computational power that the classical computer has, it is forced to reduce the number of variables that it used to create the therapy plan. So because of that, the therapy plans that we create today are not the most accurate. But if you use a quantum computer to do the job, then it can consider all these impacting variables and arrive at the most suitable, the best therapy plan a lot faster. The impact is huge. You're going to increase the treatment accuracy and drastically reduce the side effects as well, which is a significant factor. Now, if you are not impressed with this example, let me give you another one which is more powerful than this one. That is drug development. Drug development is a tedious process, a manual process that takes about 10 years to develop one drug today. And it costs about $2.6 billion. It is a manual process simply because that the computer we use today are not capable of automating this process inside a computer. In order to automate the drug development, primary problem that it need to solve is it should be able to simulate molecules inside a computer. The modern computers can't even simulate a simplest form of a molecule inside a computer. So because of that, the process has to be manually done so that it takes about 10 years to develop a drug. If you use a quantum computer can consider all these options simultaneously, and it's the specialty of the quantum computer. Because of that, you can use a quantum computer to simulate molecules, simulate drug cells, and then keep drug tests in the virtual environment and keep trying various different combinations of drugs until you find the drug. The result is you're going to create drugs in a matter of minutes. You're not going to take 10 years to create a drug. This kind of a framework will help us cure almost all the diseases known to mankind. We will live 150 years or more. There will be no premature death. We're talking about a technology that helps us create wondrous new materials. We will understand nature, weather, and we will model those things inside computers and then control them without hurting it. The things that we consider random or coincident today will have reasons behind them in the future. The countries or businesses who are going to own this kind of technology tomorrow will be more powerful than the countries who possess nuclear weapons today. That's the gravity of this technology innovation. This is the vision of the future that everyone is wanting to achieve, and that is why countries like India, China, UK and in the USA, research and development related to quantum technology has been made a national priority. With this note, let me conclude this video. If you like this kind of content, do subscribe to my channel, and in the next video series I'll be giving you more detail about quantum entanglement and its application, as well as quantum tunneling. So thank you very much. Bye bye.